number 103, it says a 0.26 kilogram rock is thrown vertically upward from the top of a cliff that is 32 meters high. So here we have our cliff. It's 32 meters high. When it hits the ground at the base of the cliff, the rock has a speed of 29 meters per second. Assuming that air resistance can be ignored, find first the initial speed of the rock, and then B, the greatest height of the rock as measured from the base of the cliff. Again, this is another very good one to know for a test. So, again, the height of this cliff, just going to redraw this here, is 32 meters. So, our rock, from a height of 32 meters, is thrown upward vertically. So it's going upward, coming all the way back down, and hitting the ground with a speed of 29 meters per second. So again, we have changing heights, changing speeds. This is a conservation of mechanical energy problem. So we're always going to start with our conservation of mechanical energy problem. KE initial plus PE initial is equal to KE final plus PE final. So, the initial speed of the rock. So, initial speed is in our kinetic energy here. Now, what, if any of these, can I cancel out right off the bat? KE initial? No, we're trying to find that speed. What about PE initial? Can we? Do we have an initial height to start with? Yes, so we can't cancel that one. What about KE final? Some of you might be tempted to because, oh, it hit the ground. No, that's silly. We're not talking about after it hit the ground. That's not a conservation mechanical energy problem. We're talking about the kinetic energy that it hit the ground with, the instant before it hit the ground. There's never a problem I'll give you in which we're talking about after it's hit the ground. That'd be silly. So we can't cancel that out. What about this guy, PE final? Do we have any final height? No, we do not. So PE final, we can cancel that out. That makes life a little bit easier for us. So plugging in our values, our equations for each of these, 1/2 mv initial squared plus mgh initial is equal to 1/2 mv final squared. Now what else can I do right now, like we did in previous problems, to make life a little bit easier? Divide both sides by m. That gets all of the m's to cancel out. Divide by m, divide by m, divide by m. When every term has an m on it, we can cancel them out. Which again, your book doesn't trust you to be astute enough to recognize that, so they give you the maths. I trust that you're all super smart and you say, hey, I don't even need the maths in these types of problems. Alright, so now, do we have all these variables? We're looking for VI. We have G, we have H initial, and we have V final. So that should be plenty of information. So 1/2 VI squared plus 9.8 times 32 meters is equal to 1/2, 29 meters per second, squared. Move that around to do our algebra here. We have VI is equal to the square root of, what's that, 14.9, 14.5, excuse me, minus whatever 9.8 times 32 is. And then all dividing by half is the same thing as multiplying by 2. So, after we do our algebra there, we get an answer of 14.6 meters per second. Make sure that we don't forget the squared there. When I wrote this step before, we forgot the squared. So again, kind of doing this in a backwards order. VI winds up equaling a square root of 29 squared times 1/2 420 26.5 minus 9.8 times 32, which is 313.6. Divide both sides by half, then take a square root. Divide by half, the same thing as multiplying by 2. When we plug that in, this is what we get as our final answer. Alright, so again, very good conservation of mechanical energy problem. Final answer 14.6 meters per second. Part B is similar, but you have to think a little bit outside the box. So it says the greatest height of the rock. We want to know the greatest height of the rock as measured from the base of the cliff. So in other words, they want to know what this height is. Now how are we going to do that? Basically, the simplest way to think of that is just consider this your initial and consider that your final. And do a conservation of mechanical energy problem from there. KE initial plus PE initial is equal to KE final plus PE final. So again, this is our initial, this is our final. At the very top of its path, it's not moving. It stops for an instant. So we can cancel out that term. We are all potential energy at the very top. Then at the very bottom, we've lost all of our height. So we have no potential energy at the bottom. So we have our PE initial, with our initial being up here, is equal to our KE final. And once we find the height here, your initial height, that will give you your height as measured from the base here. mgh initial is equal to 1/2 m v final squared. Hey, again, both terms have an m on them. Cancel those out. G is 9.8. H initial, that's what we're solving for, is equal to 1/2 v final, that was given to us, 29. Don't forget to square that. So H initial is 1/2, 29 squared over 9.8. When we plug that into our calculators, we get an initial height of 42.9 meters.